Hello everybody, I hope you're doing well and your studies are going smoothly. We're going to crack on today with some biopsychology revision, and we're going to focus today on localization of function. So here are some exam style questions you can use to practice. I would strongly encourage you, if you can find the time and the space, to pause the video in a sec, give it a go, and then come back when you're ready for me to talk through. So there you go, here's your chance to pause. Okay, right, let's crack on then. So the command word in the first one is identify, so you don't need to explain anything, you just need to state what those two regions are. So A, you can see there, is at the front of the parietal lobe, and that means that it's the somatosensory cortex. Region B, low down there on the frontal lobe. The key one you're supposed to know for the frontal lobe is either Broca's area or the motor cortex. The motor cortex is a strip that runs just down next to the somatosensory cortex, so that one is Broca's area. Okay, giving an example, explain localization of function. Well, generally, localization of function refers to the idea that certain regions of brain are responsible for certain functions. Yeah, certain abilities are localized, that's why it's called that. They're localized, they're found in certain regions of the brain. For example, the motor cortex, which is responsible for movement, is localized to the rear of the frontal lobe. There you go. Okay, now we want to describe the location and function of the motor cortex, and I've kind of done that already. But for 4 marks, you would be adding in details like, in terms of location, it's at the back of the frontal lobe and both hemispheres of the brain have one. And in terms of function, you're saying it's about movement, it's about muscle control, but add in the fact that the left motor cortex controls the right side of the body and the right motor cortex controls the left side of the body. Yeah, they project to the opposite sides of the body. They process contralaterally, you could say. Right, next row, we've got a bit of application here. So, patient, injury to the temporal lobe. Using our knowledge of localization of function, explain what the patient might experience. Okay, so knowledge. The temporal lobe contains the auditory cortex, which is responsible for hearing. Application. Therefore, since patient GW has an injury to this area, one possible effect is that they would experience difficulty hearing or processing auditory information, sound. More knowledge. The temporal lobe also contains Wernicke's area, which is responsible for speech comprehension or language comprehension. Application. A possible effect, therefore, on GW due to this damage is that they might struggle to understand speech or to engage in a conversation or maintain a conversation or something like that. But make it clear it's about the understanding, not the speech itself. Another application question. So this time there is damage to the left frontal lobes, including the motor cortex, which is in the frontal lobe. So the frontal lobe, let's tackle the not motor cortex bit at the moment. The frontal lobe contains the Broca's area, which is responsible for speech production. Therefore, one possible effect on patient VL is that they'll struggle to speak. It might be that they repeat certain sounds or that they can't pronounce certain things, but they won't be able to speak normally. The motor cortex, here's the knowledge, controls movement on the opposite side of the body. Therefore, here's the application, a possible effect on patient VL is that they will not be able to control the other side of their body very well. From the scenario, it seems like their left motor cortex, but it is a little vague because it says left frontal lobes and motor cortex. I would assume this means left motor cortex, and therefore the impairment of function will be on the right half of the body. So they may struggle to get about, they may struggle to lift things, carry things using their right hand. That's what I'd go for, and that's in terms of, the key areas of the brain that you're taught. But in other bits of the course, you will probably have come across areas of the frontal lobes like the prefrontal cortex, which does decision making and executive function. You might have come across the orbitofrontal cortex, which is involved in OCD as part of the worry circuit, so you can bring some of that knowledge in as well. I'm just going off what I tend to teach for localization of function in this lesson. Okay, explain one limitation of localization of function for 3 marks. So we want, for 3 marks, for just an explain a limitation, we want a fairly basic peel structure. So, one limitation of localization of function is that it is an oversimplification. Research suggests that lots of regions of the brain work together in a network to produce a behavior, such as the worry circuit for OCD, which contains the orbitofrontal cortex, the caudate nucleus, and the thalamus. So that's my kind of explanation and evidence. And now I need to tie it back round to actually say why this is a problem. Localization of function doesn't account for the communication between brain regions, and therefore it's a limited explanation of how the brain works. Okay, discuss a strength. So for 4 marks, we're probably looking for a peel structure again in terms of explaining a strength, but to discuss a strength, what I then want to do is go back the other way and say, okay, here's a strength, blah, blah, blah. However, this is a problem with that strength. Okay. So one strength of localization of function is that there is research support. For example, case studies from researchers like Broca on patient Tan have suggested that damage to certain regions of the brain, such as Broca's area, does indeed result in functional impairment. For example, patient Tan had damage to the Broca's area and he could only say Tan, so his speech was impaired. This suggests that that particular region of the brain is indeed linked to a particular function in line with localization of function theory, and therefore maybe it's a credible theory. So that's me explaining the strength. We then need to discuss it. However, much of this research comes from single case studies, which are unique and use flawed methodology, such as post-mortem examinations. Due to these issues, it could be argued that there is only partial support for localization of function as a theory. Okay, so I don't want to go off on a tangent really kind of talking too much about that case study. What I want to do is explain why that's a problem for this theory, because I'm evaluating the theory, I'm not evaluating the case study. Okay, next one. Evaluate localization of function. For 6 marks, I'd be looking for 2 peel paragraphs. So we've already talked about a couple. We've talked about the limitation, that it's an oversimplification, so just do that. And then the strength, maybe it's, supported by case studies such as patient Tan. For 6 marks, this is likely to be a leveled question, so you do want your evaluation ideally to be thorough and effective. So if you've got time, if you can, I would encourage you to develop one of those a little bit in terms of, for example, you could use that counter argument to the case studies that I just talked about in the previous question. But basically 2 paragraphs will be fine for that 6 marker. Okay, and this brings us to a 16 marker. Discuss localization of function. So breaking it down, 20 minutes for this, 6 marks for knowledge, 10 marks for evaluation. I would launch straight in and define localization of function. So we said this earlier. It's the idea that certain regions of brain have fixed functions or they're responsible for certain abilities. And then I would go through 3 or 4 bits of brain that I'm aware of. So you could talk about the motor cortex, somatosensory cortex, Broca's area, Wernicke's area, visual cortex, auditory cortex, and that's probably enough to be getting on with. But like I said earlier, you could use bits of brain from other areas of the course. It doesn't have to be those ones. Yeah, so pick maybe 4 of those. Tell me what they do, tell the examiner, you're not telling me, what they do and where they are, because it's about localization of function, so tying a function to an area, yeah, so don't forget that bit. So where they are. That's your knowledge. And then for your 10 evaluation marks or 10 discussion marks, you're probably looking for 3, possibly 4 evaluation paragraphs as normal, depending on your style. It is leveled, of course, so you do want your evaluation and discussion to be thorough and effective. So where you can, do try to not only use appeal style, but try to make it more of a discussion. So counter-argue. So that case study paragraph that we went through earlier, yeah? And that oversimplification paragraph is fine. Other points you could include. You could talk about how the theory is reductionist, and it's only looking at the biological kind of level of explanation, which does make sense because, I mean, we are talking about the brain, but you could look at it more holistically, and you could think about kind of the experience of what some of these behaviors are like. And actually, if you just look at, brain damage or brain structure, you're missing out on the more rich kind of side of human behavior. What else could you talk about? You could talk about how there is support from brain scanning research, so fMRI and all of that, and then counter-argue that fMRI is only based on blood flow. So we're making an inference in all of this research that the thinking is actually there. Of course, fMRI doesn't measure thinking, it measures blood flow, and therefore that might lack internal validity because we're claiming that a function, the thinking, is tied to that bit of brain when all we can actually see is blood going to that area. We can't see the thinking happening that way, yeah? Brain activity is electrical, don't forget. Okay, so we've done the knowledge, we've written a paragraph on how it's an oversimplification, we've written a discussion on research support from case studies, you could write a discussion on research support from brain scanning. You could use, if you wanted another paragraph, you could talk about equipotentiality theory. So this was put forward by Lashley based on animal research, and what he basically did was he damaged bits of cortex in the rats' brains, basically to see what would happen, and no one piece of damage really affected them. Yeah, so what he found basically was that other bits of brain would take on those functions, and even if he damaged their motor cortex, their brain would kind of get around it. And this links into what you've learned about plasticity. So you could actually bring in plasticity research as a limitation of localization of function, because that theory is that that bit of brain does that job. Yeah, and we know from brain plasticity that actually other bits of brain can take on other functions. The brain will adapt. So again, localization of function is maybe an oversimplification, maybe it lacks credibility, maybe it's only a partial explanation of how the brain works. Yeah? So you've got loads of different points that you could talk about there. Okay, so reflect, an important part of your revision. How did you do? What do you need to do next? And what are your actions that are going to feed back into the next step of your work? Right, I hope that's gone okay for you guys, and I hope that was helpful. Please do ask a question or leave a comment. Good luck with it all. Keep going. You got this. Bish bash bosh.